A screw can reach its target torque and still damage the joint. On thin sheet metal, concentrated pressure beneath the head may create dimpling, pull-through, coating damage, or local distortion. On a plastic enclosure, the same condition can cause stress whitening, creep, cracking, or boss damage. Choosing between a standard pan head and a pan washer head therefore comes down to how clamp force is transferred into the actual substrate. A standard pan head has a rounded top and a relatively flat underside. It is familiar, compact, widely applicable, and often entirely adequate when the panel is sufficiently stiff, torque is controlled, or the screw seats within a designed recess. It can also be the better choice where space around the head is limited, a functional washer is already specified, or the surface is not cosmetically sensitive. Its limitation is bearing area. A smaller contact surface concentrates clamp pressure near the hole. In thin metal, that pressure may dent or dish the panel before stable seating is achieved. Reducing torque may prevent visible damage, but it can also leave the joint insufficiently seated. Repeated removal and installation may enlarge the hole or further weaken the bearing surface. A pan washer head addresses this issue with a wider, washer-like surface integrated into the head. It does not eliminate clamp force. It distributes that force over a larger area. This can reduce localized pressure, lowering the risk of indentation, pull-through, and visible marking on thin or coated panels. It can also help protect service access covers that must tolerate repeated opening. The same load-spreading principle applies to plastic, but plastic joints require broader evaluation. A wider head can reduce compression and cosmetic damage at the contact surface. It cannot correct an undersized boss, an unsuitable pilot hole, insufficient thread engagement, or torque above the strip-out limit. Plastic may also creep under sustained load, soften with heat, or crack at stress concentrations. Head geometry is only one part of the fastening system. Clearance is another deciding factor. A pan washer head occupies more surface area and may interfere with molded ribs, recessed pockets, gasket lines, seals, or adjacent components. Engineers must evaluate both vertical thread engagement and horizontal head clearance. Where the joint sits in a narrow recess, the more compact standard pan head may remain the practical option. Assembly complexity also matters. A separate washer can spread load or protect a surface, but it introduces another component to feed, position, inspect, and potentially lose. An integrated washer head may reduce part count and handling while supporting one-pass fastening. That benefit applies only when the separate washer is not needed for another function, such as locking or a specific service requirement. Approval should begin with the dominant failure mode. If the concern is panel indentation or surface marking, increased bearing area may provide a direct benefit. If threads are stripping, attention should shift to thread design, pilot hole size, boss geometry, and torque. If corrosion is the concern, finish selection takes priority. No head style is a universal solution. Representative testing should cover first installation, removal, and a second installation. For thin sheet metal, inspect for visible dimpling, pull-through, coating fracture, underside distortion, and stable seating after handling or vibration. For plastic, check insertion, tightening, and strip-out behavior. Then inspect for stress whitening, radial cracks, damaged bosses, and interference with nearby features. Testing should use production intent parts, drivers, and torque conditions. Supplier consistency is equally important. Head diameter, thread geometry, dimensional tolerances, coating friction, and batch-to-batch repeatability must remain aligned with the approved samples. Release criteria should be written before evaluation so the decision is based on measurable performance rather than appearance. The standard pan head is often the right choice for thicker, stable substrates and clearance-limited assemblies. The pan washer head becomes more attractive when thin panels, plastic housings, visible surfaces, repeated service, or washer handling make broader load distribution valuable. The better screw is the one that reduces the joint's dominant risk without creating a new problem in clearance, torque control, assembly, or long-term reliability.